So today we're going to be taking a lot of notes, so just bear with me. It's going to be pretty long. So today we're going to go over quadratic formula. Now, if you do not know what a quadratic formula is, this is going to be your quadratic formula. Right here, I'm coloring it, that way you guys can see it. So on the top of paper, hopefully you get this paper. So that's the equation that we're going to be using it. Now, the quadratic formula can be used anytime you are asked to find the zeros, roots, or solutions. This is the solving part. When we were talking last week, we had the factoring part and the solving. Now, the quadratic formula is going to do the solving. It's not going to find your factors, but it's going to tell you what your zeros are on the graph, just like we discussed last week. Now, today we're going to be doing two things. First, we're going to figure out how to plug everything into the quadratic formula. We're going to go ahead and solve it, and afterwards we're going to figure out different things about quadratic formulas, so just properties of parabolas, in other words. So let's go ahead and start, alright, because I want to start right away, that we don't waste any time. So we know the equation is going to be that. We're going to be coming to that a lot. Now, whenever it comes to quadratic formula, there's a couple different things that you can get. The first thing is that you can get what we called two real solutions. That means your quadratic formula or your parabola is going to be touching the x-axis into different points on your graph. And we're talking about the horizontal line, the x-axis. That is where it's going to be touching. So let's go ahead and look at an example just like that. So these are the steps that we're going to be following almost every time. You're going to put it into standard form. So if your equation's not in standard form, remember standard form is right here. This is standard form. It has to be a squared plus bx plus c equals to 0. Remember, just like last week, we have to equal to 0 because we're looking for the zeros, alright? So that's the format, that's standard form. And then now we need to figure out what the A, the B, and the C are. And as you can see, it should be pretty easy to identify, mainly because they're in order. So whatever number you have in front of, oh, that's a little bit big there. There we go. If you remember, that one, and that one are going to be our A, B, C, respectively. And it's always the same order. Like, you always go from highest to lowest. And after that, we're just going to be substituting and we're going to be solving, okay? So let's go ahead and do this, okay? And big thing that you probably see here, and I'm going to highlight it because it's very important. Make sure you always reduce your square roots. Alright, so we're going to go ahead and go with the first one. So let's figure out our A, B, and C. Now, we know that A is going to be 2. We know that B is going to be this number right here, but I don't have anything, so I'm going to put an invisible 1. And we know that this is going to be C. So I know A is 2. B, or actually we do. I know A is 2. I know B is going to be 1, positive 1, and I know C is going to be negative 5, okay? So now, not all of them. And you know what? Let me color coordinate, that way you guys can see what I'm referring to. So let's go A. Let me make this a little bit wider. Oh my god. There we go. I think it should be good. So 2, 1, and negative 5. Alright, we have all 3 colors. Now, what I'm going to do, I'm going to start plugging all of this into my quadratic formula. Now, if you see the quadratic formula on the top, you're going to notice the B is going to go on the very front. So, B is going to go in the front, so B is going to be what? 1. In this case, it's going to be 1, so I'm going to put a 1 right here. All right, and then if you notice on the inside we also have 1. Now I would highly recommend you guys put it in parentheses like I'm about to do. The reason why I do that is just in case you get a negative. Whenever you get to negatives, it turns into a positive. You'll see it right now. But just keep that in mind. I would put my numbers in parentheses whenever you're substituting. All right, I substitute my B first. And then I'm going to go ahead. I'm going to go and substitute my A. A is going to be 2. So every time I see, it's going to be a 2 right here on the bottom. And let's look at the quadratic formula. And also I have a 2 right here. Now, the final one that we're going to do is C. So C, we know it's -5. So I'm going to put -5 right here. Now, I have everything already set up. Everything's nice and in there. Now, all we have to do is start simplifying. So let's go into simplify. What is 1 times a negative? It just stays the same. So it's just going to be 1 by -1. Now, what is 1 times 1? Well, 1, that's easy. Now, what is 2? Because this is what we're going to do, and I want to make sure I showcase what's going to happen. Okay, so now we're going to grab this -4 right here, and that one's going to multiply with a 2. So -4 times 2 is equal to -8. Now, -8 is going to multiply with a 5, which is going to give me positive 40, right? I believe so. So that's what we're going to get. So it's -2, that's -8, and -8 times -5 is positive 40. So that's what we're going to put right here. Positive 40. Okay. Now on the bottom, 2 times 2 is, let me go back. So that one's going to be a combination of both of them, so 40. That's 40. And then on the bottom, we're just going to have 2 times that, that's 4. Alright. So that's what we're going to get so far. Now at this point, we just need to keep simplifying. So what do we get? We get that one stays on the outside. Now on the inside, as you can see, we're going to have 41 because we're going to add them. And then on the bottom, we're going to have 4. Now, on this case, I cannot simplify my radical or my square root. Therefore, I'm going to leave it as this. But that's the same steps that we're going to be doing for all of them. And I wanted to do a color coordinator that way you would know exactly where I'm putting things on here. Now, for the other ones, we're going to be moving a little faster. So now let's go and look at the second example here. Now, quadratics can also have one real solution, meaning that you're going to get one solution regardless of what you have. Only one of your points is going to be touching on the on your x-axis. So your graph is going to be touching the x-axis in only one spot. Over here we had it touching 2 spots. Now we're going to have it only touching 1 spot. But same thing, quadratic formula, we make sure that we have a standard form. So I'm looking over here. I do have standard form, so I don't really have to do anything. As you can see, this is standard form, so we're going to leave it as this. We don't have to move anything. We're going to identify our A, B, and C. A is going to be 1. There's nothing in front, so it's just 1. Then B is going to be -6. And then C is going to be 9. Now, this is what I was talking about, and I'm going to showcase it over here on the top. So, over here, you're going to see at the very beginning, we have B equals -6. Now, what this is going to do to our equation here for the quadratic formula is that is going to turn it into a positive. So we have negative. This is the formula, right? And then we have parentheses. Let me lower this one a little bit. right, parentheses, right? And we have a negative 6. Now, the double negative is going to turn it into a plus. That's why you see a plus right there. So, let's go ahead and boom. That gives me a positive 6, right? Easy. Now we're going to go ahead and do the rest, right? So, right here, I'm going to put what? Negative 6 again. And then on A, we're going to go ahead and put 1. On C, we're going to put 9. And on the bottom one is A again, which is 1. Okay, so we have everything that we need. All we need to do is simplify. So the hardest part of the quadratic formula is just substituting everything that you have. Once you substitute everything, then everything turns out to be a little bit easier. Now we have all this. Now 6 we already know is turned into positive 6, so that one's going to remain the same. Now 2 negatives, whenever you multiply them, gives you a positive. So right here, negative 6 times negative 6 is going to give me a positive 36. Now 4 times 1, it gives you 4. Now 4 times 9 gives you 36. So we have a negative 36. Now you got to always be careful because that negative 4 or that 4 has a negative in front. So because you're multiplying whatever it multiplies to, you gotta put attention to that negative. Now on the bottom, 1 times 2 is just 2. So we have everything. Now we just keep simplifying. Let's simplify the square root first. So what I'm gonna get on the inside is gonna be 36 minus 36 is 0. Now on the outside we still have 6, so we're gonna keep the 6 there. And now on the bottom we still have 2. Now, what is the square root of 0? 0. Then 6 and then 2. Now, as you can see, I already showcased what we would do next. Now we eliminate the 0, right, because we don't care. And then we on the bottom, we're going to have what? 6 over 2, which we rewrote over here on the bottom. And then later, 6 divided by 2 is just 3. And that is my one answer. That is where my quadratic, or if you like to call it parabola, is going to be touching my x-axis. Pretty easy, right? Pretty easy. Now let's go ahead and do another example. Now, we already figured out a scenario that I have my quadratic formula touching twice. We had another scenario which is only touching one time, and if you guess correctly, the last one, we have 2 imaginary solutions, meaning that my graph is not touching the x-axis at all. So we're gonna have 2 completely imaginary numbers that we're gonna have to figure out. So here we go. First thing first, you gotta make sure that you have your equation in standard form. So let's look if we do. X squared, x, and 2. So it is, so we don't have to touch it. So we're just gonna leave it as it is. Now let's go ahead and move on to actually plugging in what we know. So if I look at my trinomial, I know A is going to be a negative 1. I know my B is going to be a 2. And I know my C is going to be a negative 2. All I need to do is start plugging in things. Alright, on the very front, we're going to put 2 right here with the negative, and then 2 squared, because that's B and B. Now after that, and we still inside the parentheses, we're going to be looking right next to the 4. The first one that goes is the A, which is going to be negative 1. And then we plug in C, which is negative 2. And then on the very bottom, we're going to put A again, which is negative 1. Alright, we have everything that we need. Now we just need to start simplifying. Now, on the front, we're still going to have negative 2. That one doesn't change. Now, 2 times 2. Well, we're moving inside the quadratic formula. Oh, the square root now. So inside of the square root, we have 2 times 2, which is 4. And then we're going to have negative 4 times negative 1, which is 4. But then, let me show it, because I always like showing this one, because people get confused. So, black, okay, there we go. So we're going to have 4 times 1, which equals negative 4. And negative 4 times negative 2. Well, negative turns into positive 4, my bad. And now, positive 4 times negative 2 is negative 8. Okay, so you're going to see it right now. So we have a negative 8 now. Now that we're here on the bottom, 4 minus 8, or let's go from the very front. So we have 2, negative 2, and then 4 minus 8 is negative 4, and everything's going to be over negative 2. Same thing with this one's going to be over negative 2. Now, let's go back. We have everything. Now let's rewrite it. I forgot to. All right. You might be asking yourself, how do you get the 2i? Where's the negative? And what do we have all of this stuff over here? Pretty simple. So I'm going to explain how do we get from here all the way to here. So first things first. Whenever you have a negative inside of a square root, this is the steps that you need to take. First of all, you need to remember that negative 1, or the square root of negative 1, is equal to I. Okay, that's one of the properties that we need to remember. I don't know, we covered this before, but we just need to know that for right now. Okay, so whenever you have a negative square root, you cannot have a negative square root. So what we're going to do now, we're going to separate this guy into two things. We're going to separate it into the positive number, and then we're going to separate the negative number, which is what? The square root of negative 1. Now, if you look at the property on the bottom, the square root of negative 1 turns into an I. So let me rewrite it just so it looks a little better. Let me put the negative first. That way you see what's going to happen here. 4. Now we're going to change that one to I. Boom. Easy. Now, what is the square root of 4? The square root of 4, that one turns into 2 and 2, which if you remember, we circled it and we push it to the front. Now, that gives me I2, or 2i, which is the same thing. Okay, pretty easy. Okay, let's go up. And that's where we get this right here. 2i. Now, the negative 2, we already had it in front. And on the bottom, we had a negative. I think there's still supposed to be a negative right there. Okay, so that's everything that we have. We have a negative on the bottom. We have a 2 on the top. Now, what we're going to do, we're going to be separating both of those things into two different fractions. So, the 2 is going to divide. So, it's going to be 2 divided by 2, which is going to be negative 1. Which in this case, it actually should have been a positive 1, not a negative. So, let's put a positive. Because as you can see, on the very bottom, we have a negative 2. Negative 2. Negative 2 divided by negative 2, that should give me positive 1. And then on the other side, we're just going to get what? I. Pretty easy. All right, we're right here. We're all back. Let's go ahead and go over what we call the discriminant. Now, what the discriminant is going to tell you is going to tell you if an equation, well, it's going to tell you the equation number and the type of solutions that you're going to get. So let's go ahead and look at what that actually means. So solutions, if you remember, that equals to x-intercept, roots, and zeros. All right, those are going to be your solutions. So now let's go ahead and look at all of this stuff. We have three different equations that we're going to go ahead and figure everything here. Now, it's going to tell us the number and the type of solutions that we're going to get. So let's go ahead and see if that's true. Okay, so for the first one, what you always got to do is put it in standard form. So let's go ahead and do that first. Now, we're going to have to move this 2 over to the other side, right? Because we don't want anything on the right side. We're going to move everything to the left, and we're going to equal it to 0. So what's the opposite of 2? -2. So let's go ahead and do that. Oof, I erased everything, but that's fine. Okay, so we have everything here that we need, right? We have the negative x squared plus 2x minus 2 equals 0. Now let's identify our a, b, and c. A is going to be -1, B is going to be 2, and C is going to be -2. Now, the way that we're going to find the discriminant, you can even see it right here, is we're going to be using that formula, and that's going to tell us the discriminant. Now, the importance of the discriminant is going to tell us that we have a negative solution, a positive solution, or zero solution, okay? So, if I plug in the discriminant here, b is 2, that would be 4 minus 4 times -1 times -2. So let's see if that's true. So go ahead, we write it out, we plug our numbers in, and we have everything that we need right there. Pretty easy. Now that we have everything here, all that we have to do is see what do we get. We got a negative answer, so we got negative answer. Now, if you remember, if we have a negative answer inside of a quadratic, that means that my numbers or my solutions are going to be imaginary. And in this case, we're going to have 2. Now, how does this look? You might be asking yourself, right? Yeah, sure, I know they're imaginary, but how do I know how they look like on an actual graph? Well, this is how it actually looks like. So you're going to have your graph, and you're going to see that your parabola, your little equation right here, is not even touching anything. That's what we call it imaginary solutions, because it's not actually touching, but we still figure them out. Okay, there you go. That's exactly how it looks. Now let's go ahead and do the... Alright, let's go and look at the other 2 examples that we have here, okay? So let's go ahead and start, alright? So we're going to find the discriminant, which is going to tell us how our equation is going to look. So first thing first, you got to make sure that you always go to standard form. Now, look at this one. Is it in standard form? Absolutely not. It looks atrocious. So what I'm going to have to do is go ahead and change it. So pretty easy. We're going to have to move the 4x and the 9. All right, so once I move to the 4x over, it's going to turn into -4x. And once I move the 9, it's going to turn into +9. So we're going to have x squared minus 6, because we're going to have to combine them, right? And then plus 9 equals 0. Now from here, we're going to identify our a, b, c. A is going to be 1. B is going to be -6. And C is going to be +9. Now, once we have everything, we're going to be using the b squared minus 4ac. So b is going to be, again, -6. Which in turn is going to turn into 36. And then over here, we're going to have 4. We're going to have 1. And then we're going to have 9. So 4 times 1 is 4. 4 times 9 is 36. So this one's going to be -36. Now, 36 minus 36 is 0. Now, if you remember, my answer is 0. If I get a 0, that means that I'm going to have one real solution. And this is going to be how it looks. I'm going to be touching at the vertex. And that is it. That is how it's going to look if you have only one real solution. Now let's go ahead and look at the final example right here. First, We check if it's in standard form. Is it in standard form? No, it's not. So we're going to have to change it. So I'm going to have to move the 2. This is going to turn into a negative 2x. And I'm going to have to move the 5 too, which is going to turn into a negative 5. So let's go ahead and see how it looks. So it's going to give me 2x squared plus x minus 5 equals 0. Now, a is going to be 2, b is going to be 1, and c is going to be negative 5. Now that we know what every single one of those is, we're going to start plugging in. So what is going to be 1 squared? 1. Then we plug everything else in. So 4 times a is 2. So times 2 is going to be negative 8. And then times negative 5 is positive 40. Now 1 plus 40 is 41, and my answer is positive. So what that means is that I'm going to have 2 real solutions. Those are the 3 scenarios that we were talking on the top, and now we saw how they work on the bottom. And you can probably guess my parabola is going to be touching the x-axis twice. You can see 1 and 2, 1 and 0 times, all right? So that's just what it means whenever we use the quadratic formula. We're trying to find those points in which my quadratic is touching the x-axis. Exactly the same thing that we covered last week. Now let's go ahead and look at actual examples. We're going to have 4 examples, and this is going to be the end of the video once we're done with all of this. And we're going to try and cover them pretty quick. All right, so the first one first, you got to always make sure that your quadratic is in standard form. So right here I have this quadratic. It's in standard form. Yes, everything's on the left and equals to 0. So let's go ahead and start working on this. Now, what is A? A is going to be 1. B is going to be 4. And C is going to be 2. So we know all those 3. Now we're going to be plugging in all those things on here. Now, quadratic formula says I'm going to have B. So right here, B. And then also we're going to put B right there. So 4 and 4. And then we're going to plug in 1 right here where A is. And then C is 2. And then on the bottom is also going to be A. Now we plugged everything in. That's the hardest part. Second part that we're going to go ahead and do is easy. You just go ahead and simplify everything. Alright. So on the outside, there's nothing to simplify. So let's move right into inside the square root. The 4 stays the same. Now on the inside, 4 times 4 is going to turn into 16. And then 4 times 1 equals 4. And 4 times 2 equals 8. So negative 8. Now I'm already kind of can see what I'm going to get it from a discriminant. Now 16 minus 8 is 8. Meaning that we're going to have 2 real solutions for this one. Right? On the front we still have 4. And I almost forgot. On the bottom, we have 2 times 1, which is just 2. And 2 is going to remain until the very end. Now, let's go all the way to the bottom. We have what? Negative 4. Now, on the inside, we have to simplify my square root. Just like we mentioned before, that square root is going to have to change. And the way that we're going to do this is pretty easy. We're going to go ahead and separate it into 2 things. Now, if you remember from class, that's not the way that we did it. The way that we did it in class, we would write the square root, right? 8. And then we find factors of 8. 2 and 4. And then we change it to 2 and 2. For every group, you push it outside. Anything that doesn't have a group, we underline it and we left it inside of my square root. So this one would be what? 2 square root of 2, right? And that's exactly what we're going to get once we do it over here. Now, the way that they did it over here is that we're going to separate 2 different square roots. One of them is going to have a 2, and then one of them is going to have a 4. What is the square root of 4? 2. And we have the little number on the inside. There we go. So you can do it either way. It works exactly the same way. But we did the factoring trees in class. Now, on the outside, we still have 4. And then on the very bottom, we have 2. Now, you're going to see that we have this 2 right here. We have this 2 right here, this 4 right here, and this 2 right here. Now, what we can do here, we can go ahead and simplify all of those together. So if I divide those numbers by 2, I'm going to end up getting 1 on the bottom, so it kind of eliminates itself. And then on the top, we're going to have 2 and 1. They didn't put 1, but I mean, you could put the 1 just to represent that you have a 1 in front of your square root. And my answer is just going to be -2 plus or minus square root of 2. Pretty easy. Now let's go ahead and go over the last couple problems. We have 3 more, which shouldn't take us that long now that we can understand what we're supposed to be doing. Now, first things first, verify that your equation is in standard form. This one right here is in standard form. Yes, we have our equation on the left and the 0 on the right. That's exactly what we want to see. Now let's see what our A, B, and C are. So A is going to be 3, B is going to be 1, and C is going to be -3. Now let's start plugging in our stuff. Let's start with B. So B is going to put a 1 right here and a 1 right here. Now let's do A. A goes right next to the 4 and also on the bottom. And then C is going to be right next to A right there. So I already plugged everything in. Now we start simplifying things on the outside and inside. On the outside, it stays the same. Okay, it doesn't change. On the inside, we have 1 times 1, which is 1. And then we're going to have 4 times 3, which is 12. 12 times 3 is going to be 36, right? And it's going to be a positive because the -4 and the -3. 2 negatives make a positive, so that's 36. Now on the bottom we have 2 times 3, which is in this case going to be 6. And now we have a lot of stuff already kind of set up. Now what we're going to do, the 1 stays on the outside, so that doesn't change. Now 1 plus 36 is 37. And then 6 on the bottom. Now, big thing about this one is that we can simplify 37. It's just not a radical that we can simplify. So we're just going to leave it as is. So that one's going to stay exactly the same. So no need to change that one. And that is my answer for number 2. Pretty easy. Now let's go to number 3. So number 3 is right here. We have, this one's pretty long. But first, we need to verify that my trinomial is in standard form. I can see it. It is in standard form, so we can start. A is going to be 1. B is going to be -1. And C is going to be -20. So those are going to be all my numbers respectively. Now that we know all of those, let's start plugging things in. I'm going to plug in -1 right here in the front. And if you see, it's going to turn into a positive. 2 negatives make a positive. So now we have a +1 in the front. Now on the inside, we're going to have parentheses, -1. And then we're going to do A. I'm going to put 1A here, 1A on the bottom. And then finally, -1 or -20 at the very end there. Let's go ahead and simplify things. On the outside is never going to change. It's just going to be 1. Now, inside -1 times -1 is actually +1. Now, -4 times 1 is -4. -4 times 20 is +80. Now we have the inside of my quadratic kind of simplified. Now let's simplify the bottom one. 2 times 1 is 2. Okay, so we have that done. Now let's keep simplifying so that 1 stays. Now 80 plus 1 is 81 over 2. Now here we're going to have to simplify 81, which, let me show you, is 9. And I'm going to show you by actually doing it for you guys. Okay, there we go. Got it small. We have 81, right? Now 81. Basically you do 9 and 9. And then we do 3 and 3. And then we do 3 and 3. I could have stopped at 9, but I just want to show it in this case. So I have this group. I'm going to push it outside. I have this group. I'm going to push it outside. So that's 3 times 3 on the outside, which is equal to 9, which is exactly what we got there. So we know the square root is going to turn into 9. We have a 1, and we have divided by 2. Now, this is what I want you guys to pay attention, very close attention to. Whenever you have it, and I'm usually only going to ask it whenever you actually have a fraction over fraction. If you had a square root that doesn't simplify, I would tell you guys just to leave it as is. Just because it's a lot easier to write it. Now, right here, I want you guys to write your two separate fractions. So what this means is that I want you guys to look at the plus and minus in the middle. That's what gives us two different answers whenever we have this, the quadratic formula, the plus and minus. In one case, I'm going to have 9. I'm going to have 1 plus 9 divided by 2. And on the other scenario, I'm going to have 1 minus 9 divided by 2. Okay? That's going to give me two completely different answers, right? So let's do the first one. 1 plus 9 gives me 10 over 2, right? The other one's going to be negative 1, or 1 minus 9 over 2 is going to give me negative 8 over 2. Now, once we divide the two fractions and we simplify, we're going to get 5, and we're going to get negative 4. So that's exactly where my graph is touching the x-axis. So I'm going to make it a little smaller, that way you can see the whole thing and can copy it down. So that's it. The quadratic formula is not very hard, and right now you're probably copying all of this like, oh, this doesn't make any sense. Now tomorrow we're going to go over it again, because I do want to go over it with you guys, but it's literally just plug it in and simplify. Let's go over the final one. So do I have to change this equation to standard form? And the answer is 100% yes, because we need to move the 5 to the left. It's not on the left, so let's rewrite it. So instead of having that, we're going to have negative x squared plus 3x minus 5 equals 0. Now, my a is going to be negative 1, my b is going to be 3, and my c is going to be negative 5. Now we just plug them in. We're going to start with with 3. We're going to put a 3 on the outside. We're going to put the 3 on the inside here. And then we're going to start with a. Negative 1 goes right next to negative 4. And also on the bottom, negative 1 right there. And then finally, negative 3 goes on right next to a. At this point, we just go ahead and simplify. The 3 on the outside is not going to change. It's going to stay to negative 3. Now, the 3 on the inside is going to turn into a positive 9. Because negative 3 times negative 3 is positive 9. And then now we start multiplying. So negative 4 times negative 1 is positive 4. And then positive 4 times negative 5 is negative 20. That's why we have a negative right there. Now on the bottom, we're going to have also a negative 2. I forgot to put it on here, so I'll put it. So the answer might change a little bit. There we go. We have a negative 2 on the bottom. Now let's go ahead and start simplifying more. So the 3 on the outside stays the same. The 2 on the bottom basically stays the same with that negative. Now the inside is what's going to change the most. 9 minus 20 is going to give me a negative 11. Now, if you remember, we cannot have a negative inside of the square root. So we're going to go ahead and separate this into two different things. So negative 1 times the square root of 11. Now, square root of negative 1 turns into I times negative 11. So that one just stays. So now we have I square root of 11. The 3 stays outside. The 2 on the bottom stays negative. Now, if we want to rewrite it, which I'm not going to ask you, if I ask you this on the test, I'm not going to ask you to rewrite it because it's just extra work. If you can get to this point right here, then you understand how to use the quadratic formula. Now, simplifying it to the bottom one is going to be pretty cool, but we don't necessarily have to do it because we already have the answer. So what would happen here is that we would have to go ahead, simplify, oh shoot, separate into two different fractions, right? You would have -3/2, and on the other side you would have what? -2, so that would be a negative, right? That would be a negative, and that one would actually become a positive. So let me erase it here, so that would become positive 3/2. And on the other one would be I over -2 square root of it, 11. Now, it looks ugly. I don't like how that one looks, so I would just recommend you guys just to leave it like the other way. I don't know if they're going to ask you to do that in college, to go ahead and simplify them even further. But for this class, I just want you guys to leave it as the top one. That would be fine with me. And yeah, and that's going to be how you're going to be doing quadratic formula. I know it was a lot of stuff that we covered, so hopefully you guys were able to copy the whole thing. Have a great day, guys.